We're surrounded by this invisible network. It's made up of devices that are constantly listening, sensing, and acting on our behalf. And it's growing every single day. But here's the thing. In our huge rush to build this amazing smart world, did we forget to secure the foundations?
No, really, just take a second and think about it. You've got your phone, for sure, your watch, probably. What about a smart speaker, your TV, maybe even your light bulbs or your thermostat? The number, it adds up fast, doesn't it? And every single one is a tiny point in this massive, interconnected web.
And that's really the core question, isn't it? We're living inside this sprawling, invisible city, and most of us, well, we don't even know who the architect is. This is where our source for today's explainer comes in. It's a dense academic work by Chuan-Kun Wu called Internet of Things Security. And its real power, what makes it so unique, is that it gives us a complete architect's blueprint for securing this city, literally from the ground up. So here's our blueprint for the next few minutes. We're going to start with the rules of secrecy, the absolute basics. Then we'll look at some common attacks on the things. After that, we'll dive into protecting your privacy, and we'll wrap it all up with the architect's viewpoint to really understand the book's grand design.
Okay, so every secure building, every safe structure, it has to be built on a solid foundation. And in the world of digital security, that foundation is cryptography. These are the fundamental rules that make any kind of secrecy possible in the first place.
The very first rule is all about confidentiality, keeping secrets. Think of symmetric encryption like a physical key to a safe. It's just one key. The same key is used to lock the safe and to unlock it. So if you and I share that one secret key, we can pass messages back and forth inside that safe, and nobody else can get in to read them.
And this little diagram shows you exactly how it works. You take a normal message, let's call it M, and you scramble it up with a secret key, K. What you get is a bunch of gibberish called ciphertext, C. The person on the other end uses that exact same key, K, to unscramble it right back to the original message. It's simple, but man, is it effective.
Okay, but what about proving who sent a message and that it hasn't been messed with along the way? Well, that's where digital signatures come in. They give us three absolutely crucial things. Authenticity, so you know who it's from, integrity, so you know it's unchanged, and this really powerful idea called non-repudiation, which basically means the sender can't turn around later and deny they ever sent it. Now, what's so cool about this is that it actually uses two different keys, a private one that only the sender has, and a public one that's available to everyone. The sender signs the message with their private key, and anyone who gets it can use the public key to check the signature. If it verifies, you have mathematical proof of who sent it and that it's the real deal.
All right, so now that we've got the basic tools for protection down, let's flip the script and look at what we're actually protecting against. We're going to go down to the device level and see how attackers target the actual things in the Internet of Things.
And believe me, the variety of threats out there is, well, it's staggering. Attackers can clone devices, they can create tons of fake identities in something called a Sybil attack, they can replay old messages to trick a system, they can forge data, they can even just drain a device's battery on purpose to shut it down. Let's dig into a couple of these a little deeper.
This quote from the book gives us a perfect and kind of scary real-world example. RFID tags are everywhere, in our keycards, our passports, and even in those automatic toll systems for cars. If an attacker clones one, they can essentially steal a digital identity. Just imagine an unregistered car driving around racking up your tolls and your traffic tickets. That's a cloning attack hitting you right where you live.
Then you have something like the Sybil attack. This one isn't about stealing just one identity, it's about creating thousands, maybe millions of fake ones. A single bad actor can pretend to be a whole crowd of devices, completely overwhelming a network or just disrupting communication. It's pretty much the digital version of stuffing the ballot box. And what's the solution? Well, it takes us right back to those fundamentals we talked about, really strong authentication. See, if every single device has to cryptographically prove who it is before it's allowed to talk, then an attacker can't just invent thousands of new voices out of thin air. You've got to prove you belong in the city before you're allowed to vote.
So up until now, we've mostly been talking about securing the devices themselves. But what about us, the people using them? The Internet of Things collects an absolutely unbelievable amount of personal data, and protecting our privacy is one of the single biggest challenges for any IoT architect out there. Let's just zoom in on one piece of data, your location. As the book points out, a constant stream of your location data tells a story. It reveals your commute, where you go for coffee, your health appointments, your social habits. In the wrong hands, that's a detailed profile of your entire life, making your behavior predictable and super exploitable.
So how do we fight back? The book lays out 3 really clever strategies. First, you can hide your real identity by using temporary IDs that are constantly changing. Second, you can actually inject noise. Just send out a bunch of fake location data to confuse anyone trying to track you. And third, and this one's my favorite, you can use fuzzy locations.
This image shows that third strategy perfectly. Instead of broadcasting your exact spot, let's say N1, your device just reports a general area. For something like a map app, that's often good enough to work, but for a tracker, you've basically vanished into a small anonymous crowd. Pretty smart, huh?
And this all brings us to the most important takeaway, the big idea. What makes this book's approach so powerful isn't that it just lists a bunch of threats and solutions. It's that it provides a complete, honest-to-goodness architectural blueprint for security.
The real value here, the reason we're talking about this book, is its systematic framework. Yeah, it's academic, but it's organized with an architect's precision. It shows us that you can't just run around patching security holes after the fact. You have to design a secure structure from the very beginning. That structured thinking, that's its unique contribution.
Just take a look at this table. It breaks the entire chaotic IoT ecosystem down into 3 logical layers. First, you have the perception layer. These are the actual devices sensing the world, where physical threats like cloning are your main headache. Then there's the network layer. That's the communication highway, and it's vulnerable to things like eavesdropping. And finally, the processing layer, up in the cloud, where making sure data isn't tampered with is everything. Each layer has its own unique security challenges.
By thinking in these layers, we can apply the right security measures in the right places. Suddenly, this chaotic mess of threats becomes a structured engineering problem that we can actually solve. This architectural viewpoint, it's the key to building a smart world that's also a safe one.
Which of course leaves us with one last big question. As all these different devices and networks and platforms merge into one giant connected city, who's ultimately in charge? Who's the chief architect? Is it the companies that make the devices? The people who own the networks? The government? Or is it us, the actual citizens of this new digital world? It's definitely something to think about.